Let's take a look at the next section in chapter one. So we've been talking up to this point about the representation of matter as far as elements, composition, mixtures, different bonding that can happen, things of that nature. But there's also another side of chemistry that we're going to explore now. And that's the energy involved in both physical and chemical changes. So let's take a look here at what energy is. Energy, as we define it, is simply the capacity to do work. Work is very simply defined as the action of a force over a distance. So that's what we see. This gentleman here is pushing a box, he's applying a force and moving something over a distance, therefore work is done. So when you bicycle, down the street as well, when you pedal, that's also some type of work being done. So there is two different classifications that we can discuss here. For energy, we have kinetic energy. This is the energy associated with movement, of motion. There's also potential energy, energy that's stored in a bond, for example, between two atoms. That's considered a potential energy source. It is relative to position. So when we talk about thermal energy, this is another specific type of energy that might come up where we talk about the temperature specifically of an object and a transfer of energy as heat. So we see this image over here to the right where we have this item at the top here, this anvil on top of a building, and it has a lot of potential energy due to its position. It's unstable. So some compound that's unstable has a lot of potential energy, versus after it reacts and it becomes more stable, right? It has less energy. So we see that as this anvil falls down off this building, the potential energy is converted to energy of movement, kinetic energy. So that's what those movement lines are showing us there. That conversion to this kinetic energy. And then once the anvil hits, we can see that heat, due to that friction force, is transferred into the pavement there. So that's what those red arrows are indicating, this thermal energy transfer. But what we can see is that energy overall is not created or destroyed. It's just transferred from one type to another. So a car is a great example of this conservation of energy and transformation from one type to another. So our gasoline has potential energy, the bonds within these carbon to hydrogen compounds, these hydrocarbons. When we do combustion in our internal combustion engines, we actually break down these gasoline molecules, but we transfer that energy in those bonds. We release that energy to eventually generate the movement of the vehicle, right? We have that gas explosion inside of our engine. So some of that energy gets transferred to heat as well. So that's how we can turn on our heater. We can also transfer some of that gasoline potential energy to electrical energy. We can turn on our radio. We can turn on our wipers. We have some other forms of mechanical energy happening. And then after those molecules combust, they were unstable in the gasoline, but now they're more stable and they leave our exhaust as CO2 and H2O. So this energy is conserved, it's just transformed. So whatever was in the gasoline has changed form. Um, so overall, then we can reference back to what type of energy is chemical energy. We can see that chemical energy, the energy stored in chemical bonds, we can classify that as potential energy that can be released. Like so when the gasoline is combusted or reacted with oxygen. So we'll pause here, we'll come back and we'll talk about the next PowerPoint.